Hey folks, welcome back. I got a quick video for you here with two machining operations, which I think you might enjoy.
There's nothing quick about this.
First one is I have to do some fairly precision grooving, in some Harley transmission gears. I think they're the output gear where one of the pulleys for the primary belt goes, or chain, whatever the hell's in there, I don't know. And it's to modify the gears to accept an O-ring so it prevents oil leakage. And I don't really know where it leaks from. I don't understand the location of it because I don't work on Harleys, but if you do, you'll recognize the gear. They are harder than a coffin nail, so we're definitely using some carbide. It barely works. You'll see my struggle. The struggle is real, but we do get it done in the end. Now the second one, we're making some remote idle adjusters for some S&S super carbs. I'll explain the reason why you need these when we get to that point, or they need these, I should say. So let's go ahead and get right on with the machining. Oh, I forgot to mention, after these two sections of machining, I'm going to go ahead and stick some riding clips in from the last trip I just took up to North Carolina. The first set, I believe, will be the ones from the Insta360 camera on the Sabre, and the second set will be from the Innov dash cam system on the Concourse. So this would be a good spot to put them. So watch for them after the two segments toward the end of the video. Okay, welcome back. Got a couple of quick lathe jobs for you.
There's nothing quick about this.
And this has to do with gears. As you can see, I got two of them right here. Now these are Harley gears of some sort. They go in the transmission, I guess, because it's got backside where the dogs go, where it would link to the next gear in the drive train or the gear train. They got a thread on the outside of them. I know they stick out of the, I don't know, the primary or the transmission, because what we're going to be doing is modifying older gears that are in good shape, or used gears, to accommodate this O-ring, which is sitting right here, that goes in that slot right there. So this is a store-bought, if you want to call it that, aftermarket apparently, Andrews gears, so it says right there. And so this is what my neighbor down the road at the Harley shop buys, because apparently this is a critical factor on these as far as oil leaks go. There is a seal, well, not on this one, but you'll see it on these. There's a seal that goes in the end there for the inside of the shaft, but as far as the outside goes, where it penetrates through, however it does that, I don't know. It needs an O-ring right there. And when it doesn't have one in the original gear configuration, I'll show you one here in a sec, you have a leak potential. I got another one over here. Actually, I have quite a few of these. Well, 1, 2, 3. I think I got 3 or 4 of them right now. Yeah, 4. All right, here's one here. I got a little Prussian blue on it for a reason I'll explain here in a second. So there's the back side of it. I guess this is a stock gear. It says DI65BP on it. I don't know if that means anything to anybody. But anyway, right there, that looks like it's an O-ring groove, but it's not. It's just a relief that was machined in there, or some other feature to create that shoulder. I do not know. He said that is not the correct depth or width for an O-ring, so it will not work that way. It has to be machined out. It has to be made to look like that. And he said, why don't you just chuck it up in the lathe and, you know, go about your business and do that. And I said to myself, there's no freaking way you're going to be able to chuck this. It would be a cold day in hell before you'd be able to get this concentric and actually have it hold. Main reason is you got pointy tips here and you got pointy tips there. Even if it was going to go between the teeth of the gear, it would have to be the right tooth count divisible by 3. I don't even know if it is. And I would never do it that way. It's just not good enough. And if this thing moved while I was doing that cut, it would ruin the gear. He said, in fact, this spot right here cannot be touched. The edge in front, this surface cannot be touched. It has to be left alone. So I have to come as close to that as possible. Now I've already done one. I'll show you the result of that. I did it yesterday. This is a scrap gear. I asked for one that's a scrap gear so I could try it. And he said this one would be fine. You see the back side's all chewed up. And then I got a pretty good groove on it, and it's the right size. So anyway, I'm going to show you how I do this, because I thought it came out pretty good. And we are going to use an arbor that I made recently. Let me move these guys out of the way without stabbing myself on the live center. This is an arbor that goes obviously in the 3-jaw, and it has a diameter, which is the exact same diameter has that brass or bronze journal surface in there. And you slip the bitch on and you hold it in place with this nut and go about your business. The only problem is, because I turned the lathe in reverse with a parting blade, that's what we're going to use on this, is a parting tool. And I'm not going to switch it around because this thing does not like parting in forward. And it would not like doing these grooves in forward either. Forgot about that when I made this, and I should have made this a left-hand thread. Let me put it in a chuck. And this thing is turning backwards, like that. And you have a tool coming in. It's putting load on the part, and the part wants to do this. And that is the loosen direction. Now I did this one yesterday without modifying it because I put a pin in it yesterday. I'll show you that here too. And it did not spin. It's probably because the backside's so chewed up it actually kind of grabbed into that metal back there. It's just big enough where it catches the flats. I'll show you on a better one. So what I ended up doing yesterday is I ended up putting a pin in. It's a hardened pin. And I ended up putting that in. It's a 3/16 pin. And what that does, if I slip one on here, is because it goes up and it locks against that surface. Because it wants to turn this way, all you got to do is set it in that location, then tighten this up. If it wants to move, it can't because it's up against that pin. So essentially one of these cogs in there is up against that pin. And that's just a safety factor for it. So I'm going to go ahead and do one on camera and see how it works out. And I'll show you a little trick on how we're going to pick up the parting tool on this edge right here and make sure that we're not going into this face. Okay, so the first thing, and the way I design this thing as far as figuring it out, when you go directly up against the chuck, you're just slightly proud right there. So this thing can't move in anymore. But we can't really rely on that to square it up because some guy who was operating the lathe actually hit the chuck inside there turning something, so I don't know how square that is. So what we're going to do first is put an indicator on it and bump it around, make sure it's true. Tighten the bejesus out of it and then use a live center. Put it between gears, El Neutro. You can see you can't check this thing true every time. It just ain't gonna happen in a 3-jaw. I would really like to get a 6-jaw for this on a D1-4 cam lock. Eventually I will, but I don't have one now. So there's your high. Whoops. There we go, that's good. About a thou, close enough. So now we're good. We'll tighten the bejesus out of it again. Yeah, she's tight. This guy out of the way. So now this is true. They're close enough. Let me slip the scrap one back on and show you how this goes before I put a live one on. Now this I wish the washer was a little bit bigger, but there are some fat sections here between the spline. I imagine this is maybe this is where the primary belt goes, belt pulley rather. I don't know, but it's enough purchase on here where it doesn't give you a problem. There you go. Now, oh, that's tight. This is 1 inch and I think 4 thousandths is the diameter of what I needed to turn that more precise surface at for this, this brass or bronze bearing journal in there. Like 1 inch 4 thou. There's a couple of challenges with this because of that. Number one, that seal that's in the end here. I did not want to have to push the seal over the shaft, so that's what this relief is for right here. Nor did I want to drag the seal or the inside of that bearing journal surface over some threads. So since this is 1 inch, I decided to make this 7/8, so 0.875. I'm just going to single point that, and I had a nut that I thought was a 7/8 16. Turns out it wasn't, but I cut this 7/8 anyway, and then said, whoops. So I took a nut that's a metric nut, and then just bored it out because it was much smaller than this. And then single pointed 16 threads per inch, or 16 TPI at the appropriate diameter. This is one place that AI does come into play, because I hate AI. I think it's going to be the end of humanity. But I put that into the AI thing in the Google machine. 7/8/16 isn't really a common thread. You can buy 7/8/16 taps. I don't need one because I can single point. But if you look on your traditional tap and die charts, you don't find 7/8/16. You find 7/8/8, 7/8 something else, I don't know. So it told me what the diameter needed to be on the ID here to turn this to, so I could thread it at 7/8/16. And it came out pretty damn good. I mean, the thread pitch and everything is perfect, and there's like, I can't even feel any movement. So it's a really good thread. So that's why it's the way it is, and of course a live center for the live center on the tailstock. Okay, so let me go ahead and get one set up that we're going to actually do. But before we do that, we got to do a little stone, dude. Okay, here's our first victim, but they do have some, wear and damage on the inside of them. And since we referenced basically off the little spot right here, this part of the flat, because this is the only piece I had that I can make this out of. So it just references a little bit of the flat of the back of the gear, which is all I need anyway. But because we got some high spots, we got to stone the back side first. Doesn't hurt the gear. Now let me tell you what, these gears are harder than a freaking coffin nail. I mean, they are really hard. I really wish I could test the hardness on them with like a Rockwell gauge or something. But what am I, Adam Booth? Can't afford that kind of crap. Wish I could, but I can't. Someday if I come across one at an auction or something, I might just bite, but not now. So I got it all clean and stoned, dude. We'll ring it backwards. Now could it turn a little bit when I tighten this up? Maybe, but it's going to be close enough. Let me get something to tighten that with. I'll use my brand new crescent wrench. Yeah, it comes this way with a factory patina. I wish I could tell you where I found this, but I can't because I can't remember shit. Sweet. Okay, I just put a new insert in, parting blade insert, and I am very, very low on these. I gotta go inside here momentarily and order another couple of packs of these, because essentially you're gonna get one gear out of every side of the insert. Just a double-headed you know what. And so I can get 2 gears out of one insert if I don't break it. And so far so good. I've already set the height for what I used yesterday. This would not be typically the height that I would use to part with. I am higher so I can get a little bit more positive rake on that tool. It just worked better trying it on that sample scrap piece. What we got to do is we got to make sure this is properly squared off, or perpendicular I should say, with the workpiece. Okay, tighten this thing up good. I gotta set my Z. Make sure that I'm not gonna be cutting into that shoulder right there. So I'll show you a little trick that I learned from Stefan Goldschlager, whatever the hell his name is, on YouTube, where I can get a really accurate location of where that parting blade is in relationship to this shoulder. Okay, I had to move the live center out of the way, but that doesn't matter for this. So I've got my new indicator I got from that Precision, whatever it's called, machinery auction. I just took it out of the box. It's a Starrett 708B dial indicator. Is a nice indicator. And it's very, very sensitive. Has very fine resolution. So I've got that zeroed out on the blade of the parting tool. So what I'm going to do is I'm going to bump off on that shoulder, and that parting blade is going to deflect. You can make that happen by just pushing on it. So if I do this, see how the indicator moves? You can pick up a surface with a blade like this very, very accurately. I'm doing it this way. So I'll just bring it in and we'll just kind of bump this in. There we go, see it just moved. So now we're touching. Back off, now we're not moving. Now we're just touching. So I'm going to back it off and put it right there because I have to account for a little bit of flexion in this blade. You can see again, here we're touching, here we're not, so I'm going to leave it there. We'll go ahead and lock the carriage. And that's a really good way to set a tool like this as far as your location against the shoulder very accurately. So that was a really good tip from Stefan that I've used a couple of times off camera. Hopefully it'll work out on this situation. I think it will. Got a good push in the bush. So what I'm going to do is I'm going to put a little dicum in here. Okay, here are the dimensions rather on the groove. The OD is 1.407 imperial, obviously, and the width is 90 thou. I verified that 2 different ways. I used the calipers, and I also used a pair of regular calipers. That's what we're going to do to get the final dimension on this. You can get very, very accurate results with a pair of calipers like this, as long as you get the right feel. I have these preset. The width, I can use a drill bit for. This is a 89 thou drill bit. Doesn't even come close now. And because the parting blade is 80 thou, technically I just need to move away from that, away from the chuck. So negative Z, or positive Z rather, negative is always toward the chuck. Because this stuff is so hard, we're gonna have to do that trial and error. And also on the depth too. So I'm going to run 270 RPM in reverse. Let's give it a shot and see where we're at. Definitely not touching there. Just started touching on the inside. Okay, let's set next. Depth. Try to go in. She don't like it at all. I'm gonna run to 200. I can't remember what I did yesterday. I think it was 200. I mean, these things are hard, but the surface finish is fantastic in there. It really is nice. Definitely need more. I'm going to measure with the calipers too and see where we're at. This is kind of hard because the width of the groove is not where it needs to be to really get these in accurately. But it gives you an idea. 1.485 according to that. I need to get some hearing protection on. Yeah, I think the chips wiped off that blue, but I don't really see that surface being impacted, so we're going to leave it right there. So now we're at 470. $455. They were definitely big. Good. Okay. Set the wife. Oh wow, we are just about there. And when it gets down inside there, it is softer. Let's check that with the calipers. Yeah, I can't get in there good enough to do it. Let's go ahead and widen the groove and then we can see that better with the caliper. We may be right there right now. I certainly hope I didn't go too far. We're already set on the Z, so let's move. Yesterday I had to move about 15 thou to get this to do it, but I'm just going to move the 10. Okay, we're touching now. According to this, I'm at 20, 420, but I can't really rely on this right now. The groove isn't to width yet. Oh man, this is showing, well, this thing might have gotten knocked out of keister here. Okay, I just reset these calipers to the sample. I may have gone too damn far. I hope I didn't scrap this one. Fark. Well, let me see. I just can't get these in, but it's reading, these things are reading differently. I do have some space in there. Let's check the width of the groove. Yeah, we gotta go more. Try this. Yeah, we're about there now on the width. Should be able to get a better measurement. I need to get some calipers that are designed for very, very thin grooves. Well, this is showing 405. Well, we're 2 thou under, but I think that'll be okay. This is showing 405. Yeah, so I'm 2 thou under, maybe 3. That's all right. For what it is, I think it'll be fine. These are very hard to measure, but you can get these guys in here too. 89, good enough. So that's the groove width according to calipers. 89, 88, good enough. Take the burrs off with a stone. Yeah, I think we'll be fine with just a couple of thou under. But it cut a lot better than the one I did yesterday. There may be different, heat treating on different ones. All right, let me clean it up and we'll try that O-ring on there. So there's your O-ring in the groove now. And the groove width is proper. So I don't think you'll have a problem with that, but we'll make sure we do a better job on the next couple. Yeah, there's quite a bit of squish there. Yeah, so I think that'll be fine, and I'm happy with it so far. But that's how I'm doing it, and that's how I did it. And now you saw me do it. Now I'm refining the operation so I can get it even better. Let's move on to something else. Well, let's talk about something real quick before we move on to the next project, machining project. The main challenge here, I'm thinking about this, is the reason why it's kind of hard to hit that number exactly is because of the amount of tool pressure it takes on a parting blade like this. Any type of a carbide tool with that hard of a material. I've already delivered them down the road to my neighbor, but to his shop, but it would be nice to take one of those to somebody that's got a hardness tester like I was mentioning earlier. See exactly what the Rockwell is on them. That would give me an idea what kind of tooling I would need. It obviously works, but it's hard to hit that final dimension because when you get close to it, let's say you're 3/4 thousandths away, that's probably close enough at that point on the big side. I'll probably in the future leave them there, but if I really wanted to hit that dimension dead nuts, it's kind of hard to do because it takes so much tool pressure, pushing inwards on the cross slide for it to take a bite. And evidence of that is the chips here. When you take a look at the chips that come off, these chips are extremely thin. The chips are 2 thou as far as the thickness of them. We're not able to really get an accurate final cut is what I'm trying to say here with this setup. Now, I'm still convinced running this parting tool backwards or upside down and the lathe backwards is the way to go. And the reason why is, number one, it's the only tool I have to do this, and number two, if I flipped it around and traditionally and moved this, rotated this clockwise or counterclockwise to you, but in the normal fashion, big potential for it to dig in and dive down like I've explained in other videos. And then we break a tool or we damage the workpiece. This way we have deflection upwards and it will tend to not do that. And of course it did not do that. I did 5 or 6 of these things. I think I did 1 off camera and then 4 more, so 5, yeah. It obviously worked deflecting upwards a little bit, but the trade-off is you have to put so much tool pressure on that when you get close, as I said, it's easy to go too far. So if I have to use these inserts, I just ordered a bunch more. Because I can't find any, what do you call it, ceramic inserts that are this width as far as parting inserts. If I could, I'd order a whole new set, like a tool holder, the inserts themselves, if they were ceramic or something harder. I'm going to do a little bit more research on this, but right now this is the way I got to do it. So this is the best way to do it when it's deflecting that way for safety, but not necessarily for getting that final cut because of the tool pressure. So I just wanted to go over that. Now let's go on to the next project. Okay, this is an S&S Super Carb that goes on Harleys, I guess. I don't know anything about these, but the task at hand is to make extensions for the idle adjuster, and that's because of some space limitations from these enrichers. This is a typical one you find on these that you pull up and you pull over to the side. You know, it's got a little pin going through it and holds it up. It has a couple of stages there. You can kind of see it right there. So that'll be full enrich in the first position, second position, and then, you know, your run position is right there. And because of these and other ones, I'll show you another example of one, which is this guy right here. It also has those little steps like that. There is space limitation to get in here and adjust the idle. Now, apparently, from what my neighbor said that does all the Harley stuff, this is in a performance engine application. But if it has one of these carbs and it's got like a performance cam, maybe higher compression, something like that. He said really common to have to bump the idle up while it's warming up, even in concert with the enricher. And to do that with a screw that goes down in there, which is an 832 screw, regular slotted head screw. Well, that is very difficult to get at, especially with whatever else is, you know, in the way, the tank or, you know, whatever goes on the back here as far as like an air box or air cleaner or something. So what he wanted was something flexible that could go in here and act as a remote idle adjuster. So while it's warming up, the owner can, you know, bump the idle up a little bit, and then once it warms up and this is off all the way, you can back it back out and get the idle where it's supposed to be. And so I've already made a couple of these up. Let me move the carb out for now. Let me show you the screw first. You know, it's on the end of this magnet here. Typical 832 slotted head screw, that's what you find in these things. We're going to replace it with something like this. This is one of them I made, I don't know, a week or two ago, 3 weeks ago. This particular one has got a thread problem. Doesn't want to thread in. I don't know why, because it worked on my test nut. But I'm going to go ahead and fix this one off camera, but this is just an example. I made a couple of different lengths. These are made out of brass and a piece of speedometer cable. And then I paint the center section with some silver paint, at Tester's model paint, at not epoxy, at enamel, which works really well for this stuff. And I knurled the head on them, and essentially it's soldered in on both ends. I made these longer. He ground this down to the length he actually wants, because we don't need that many threads. And the reason why it was longer to start with is I based it off this tool, or this part right here. This is an aftermarket solution to that. So here again is the carburetor, and if you get down in here with this guy, it ain't the easiest thing in the world to manipulate. You can see that it's awfully close to that. And so getting in here with your fingers, he says, it's just really hard. Now a couple of them that I made, again, that were shorter, he used one of them and he said it was perfect. He didn't really give me a specific length, but I'm going to go ahead and make one or two more up that are shorter than the one I just showed you. Shorter than that one. I already have the head of one of these made already. I wanted to do something a little different. I guess I should say the knob, not the head. I did this a few weeks ago, and I took a stack of pennies and soldered them together. This one is a 2000 and something. It's a little smaller diameter because, you know, I had to turn it down and try to knurl it a little bit. And I've got a piece of brass. I threaded this in. I forgot. See, it's been so long, so I can't remember. So I threaded that in. This will ultimately get Loctited in place because I need to separate this so the solder won't melt. That's what it was. You know, use the solder on the speedo cable on this end. Then I can put this on, and then that'll be kind of cool. It's got, you know, Honest Abe there on the end. And I'm being honest with you. This is going to work. So this is one we're going to use right now, so I'm not going to make a head in this particular one, but this is kind of cool. We're going to go ahead and make the other parts for this. So I got my Wheels Through Time mechanics diary here, and I did write this stuff down, luckily, you know, a month or two ago whenever I did this originally. As far as the 832 thread goes, we're going to single point this thread. Now, it'd be easier to use a 832 die. I don't have one. I have mostly metric shit. When I'm on 29.5 degrees in the compound, which I am right now, I always keep it set there unless I'm doing something funky. I have a 24 thou in feed from a blank piece of brass, which is this 1/4 inch stock stuff you just get at a hardware store. You have a 44 thou per side in feed to get down to 0.162, which is the major diameter. And again, that's from 0.250 material, or 1/4 inch. Okay, so I got a piece of stock that I already started. I started on it and I got interrupted by something. Again, weeks ago, I can't remember. And I already have a center in it. We definitely need a center in this because this is unsupported without it. And so we'll just chuck this up at the right stick out and then we'll get started. Man, I just cleaned these damn jaws. All right, I gotta take these jaws out again. They're all bound up with chips. All right, we'll set the depth here of how much I want to, how deep I want to turn it down on the Z axis. Touch off and we'll turn this down to 162. It's a good day to do this. This is what we got going on right now. Tropical storm looks like it wants to form up out in the Gulf. But we need the rain really bad. So that's what we're dealing with. It's a good day to sit in a garage workshop and do some machining. 41.5 thou per side brings us down to 162. Let's see where we're at. Yeah, 175, which is exactly what we have left based on that calculation. Now I know this is dumb, single pointing this. When do I not do dumb things? Actually, it's 165. That's that's part deflection right there. Perfect. 162 and about 3/10. That will work. Okay, two things I forgot. I need to move this out and do the threads longer because I want to eliminate the end here that has the center drilled into it, even though it's not very deep, but I don't want that center to remain, so we'll grind that off later just on the sanding machine over there. But so I have to thread this longer, so it's a little more waste of material, but it's the way it is. And the other thing is I'm using a high-speed steel threading threading cutter. That is, I ground this down myself to a slightly negative rake. This way is better for these softer materials. And I've used this before, works pretty well. And so the reason why, of course, is because of the live center. I cannot get my traditional threading tool in that would be used for finer threads. Now I can get my big one in there, which is this guy right here. This is designed for much larger, much greater pitch thread, like something around an 8 TPI, 5 TPI, something like that. Or in metric, maybe a 3.5 or a 2.0 or something like that. Really, really coarse thread. Rarely ever use it, but when you need them, you need them. And I can't use that here, so I had this laying around. This is the one I used before. It's already on center, and I know my tool holder rather is square from yesterday when we did the parting operation or the grooving operation on those gears. We'll run at 270 and I'm set at 32 TPI. Okay, 0 on the DRO, 0 on the cross slide, and 0 on the compound. Okay, I just reviewed my notes, and 24 thou in feet on the compound, which remember is at an angle, 29.5 degrees. So we will come back to 0 on the cross slide and advance the compound as we traditionally do for threading, and I'm all set up for 32 TPI. Now this is divisible by 8, so we can pick up on any large number. 1, 2, 3, or 4. And get some of those chips out of the way. And when you're doing something on a thin workpiece like this, I've already advanced 15 thou. Every now and then you got to do a spring pass to let the cutter catch up. Otherwise, it'll eventually kind of overpower the deflection of the workpiece, and then you'll take a really deep cut. So let's go ahead and do just a spring pass now. We're at 20, let's go to 20. Yeah, well, I've already proven it out at 24. Let's just go 24. I'll leave that right there for now. Let me find my test nut. A little tight as it goes up. And that's again because of part or workpiece deflection. So we need to run a spring pass or something over that, or just take another thou, something like that. That's probably what happened on the one that doesn't want to fit that I showed you before. Probably just started the nut and said, oh yeah, that's good enough. Here we go. A little looser than I'd want it, but you know, for what it is, it's fine. Yeah, it works. It's a little looser than I'd like, but it's no worse than that aftermarket piece of crap. And you know, it's gonna have a spring on it anyway. And when you turn this, it moves the throttle itself here. I can't get a good grip on it, unfortunately, but that spring is fairly stout. You can see it goes in. It'll work. This is why I want to get rid of this little end with the hole, because that blade down in there, kind of hard to see it, but you can see it a little bit right there, just below the cable hole. Right about there. Fairly narrow and sharp edge, and what that'll do is that's too high of a contact area on a soft material, so we definitely want to flatten that out. That's why I made it longer, so I could do that. Basically like that. Okay, so before we part this off, we need to do one operation over on the mill, and I'll explain why I want to do this here in about, I don't know, a few seconds for you. So what the hell are we doing over in the mill? Well, we're going to mill some flats, 6 flats for a hex. Make a hex for a little wrench like this. And the concern is if one of these got jammed up for some reason, the threads got buggered by somebody, or they let the bike sit for a while, the aluminum corroded around it, this would be very difficult to get out by forcing it through the torsion of this speedometer cable. Because these things will delaminate internally. You know, they will. It's just the way they are. They're layered. And I just don't want that to happen. So I want some way somebody can grab it with a wrench and get it out if necessary. I want to mill this for a 3/16 hex. Unfortunately, I can't find my 3/16 wrench. Little ignition wrench like thus. So this is a 4.5 mil, which is 185. So we'll make it a tight fit. and a 187 or 3/16 wrench will fit just fine. It'll be about a wrench width up from the shoulder, and that's what we're doing. So we'll flip this around 6 times and do that. That's too slow. Touch off first. Depth of cut is 30 on each flat. We'll take that in one pass. We're just locating against the edge of the vise. That gets us our X location. No need to move the table at that point. But we will do a little tappy tap tap each time to make sure it's flat. Yeah, it should be a fairly snug fit on this 4.5, which it is, and a 3/16 will definitely work. Or they can buy themselves a damn 4.5 mil ignition wrench and be done with it. But you know these Harley guys, they don't like metric shit too much. It's good. All right, this is the length that I decided on. Drilled that out with a .120 drill bit, and that cable goes right in there pretty firmly, as you can see. We'll go ahead and put some flux on it. This is simply just acid core solder from the hardware store, or from wherever you choose to get it. I'm just going to use my little torch, which is being a little bit frustrating here. Let me back you off a little bit, because it's fixing to get hurled into the woods because it doesn't want to start. Piece of shit Chinese garbage. That'll do it. I know it gets on the hex, but we'll wire wheel that off once it cools down. It just wicks itself up in there, and this turns a little blue. We'll wire wheel that off too. Plus I'm going to paint it. Let me let that cool down. We can do Honest Abe side. Same deal on this. And by the way, since it's in the background here, if you're going to cut speedo cable for any reason, you're going to need a zip wheel like this. You're not going to be able to do it with a pair of cutters. You got to cut that off with something like a diamond wheel or similar, whatever that's made of, because it just won't cut. But that will. This thing fixing to get launched. Let me get that blurb off, that blob off of there. Good. That's it. Okay, here is Honest Abe Remote Idle Adjuster version 1.0. Paint is still wet, but it'll dry quick, and then we'll let this Loctite 271 up in the head of it there cure overnight, and this will be ready for delivery. We already know the threads fit because we tried that before, and come out pretty good. And you know, you have some flexibility here, so you can reach in, do a classic reach around, do your adjustment, and yeah, that's a lot of fun. So I thought it'd be kind of cool to try it with you know, something a little different than just making a brass, you know, a brass tip on it, brass head, you know, knurled. I did the best knurling I could because I had to chuck it on this part, which ain't all that solid, and it'll work. It'll definitely work. You can get a purchase on it, so I'm not too worried about it. But that is kind of neat. I do like that. So that's that. We'll let that sit. And that's pretty much going to conclude the machining. that I have for you in this video. All right, that's it on this one. Hope you enjoyed the machining segments and the ride videos. And stick around for more stuff. You know what to do if you want to do that. With the like, share, subscribe, comment, and maybe the algorithm will be more kind to me. I don't know. I don't think YouTube algorithms are designed for kindness, but that's just my opinion. All right, so again, stick around for more crap. It's coming up on the channel soon. As always, thanks for watching. Don't just repair, restore. We'll catch you on next video. We're up here at the Big Lynn Lodge, finally. And we just had dinner. And we are going to sit a spell on the rocking chairs. 73 degrees right now. It's like 90 million down home. I just got you a little view of the view from that way of this valley. Not too shabby. I figured out a way to put the camera on the Sabre. That's what I'm going to try tomorrow and see how it records. So we'll pick it up from there. Loafers Glory, North Carolina, where the glory holes of loafers reside. Very cool. Yeah, we're at Bonnie and Clyde's Drive-In in Loafers Glory, North Carolina. And we've been loafing after having a cheeseburger, mushroom Swiss actually, and some tater tots, which I shouldn't have had, but I did anyway. So yeah, pretty cool shit. Been here before, and we're gonna get rained on, so probably time for us to go. And let's change this. Yeah. We're gonna get some rain. Okie doke. Say goodbye from Loafers Glory, North Carolina.
You not. Huh?
Catch you later.